G'day aerosexuals and welcome back. So why is it that these big wide body aircraft like the 747 fly so much quicker than what a 737 flies or other narrow bodies? And really it links to what we were talking about yesterday with coffin corner, where as an aeroplane increases in altitude, its envelope of airspeed starts to shrink. And today we're going to talk about that max operating speed, which is closely linked to the critical Mach number, which is really the point at which airflow over the top of the wing starts to accelerate and approach the speed of sound. Now, there's a few tricks that engineers have designed into planes that help trick the aeroplane into thinking that airflow over the top surface of the wing is slower than what it really is. And one of those is wing sweep. Now, if we look at how much these wings are curved back towards the tail of the plane, on a jumbo jet, it's 37.5 degrees. And if we compare that to a 737 or similar, it's only 25 degrees. And the reason for that is because when it comes to compressibility effects of Mach number, it only really cares about span-wise component, which is the vector of airflow that goes from the tip of the wing straight backwards at 90 degrees, coupled with chord-wise component, which links up with a vector that goes from the front of the wing to the back of the wing. In essence, if we were to draw a triangle, we're now adding distance to the vectors, which if we're adding distance and using the same time period, it's tricking the airflow into thinking that it's going slower than what it actually is. And the second component we'll talk about is a supercritical wing design. And this is really nicely demonstrated on a 747, whereby the top surface of the wing is incredibly flat and then it tapers off at the back. And what that does is it distributes the acceleration of the airflow over the top of the wing very evenly, and it prevents any shock waves from forming from fast acceleration at the front of the wing to really the back of the wing. And if we compare this to a 737, it's actually got quite a short stubby wing where airflow starts to accelerate far quicker, and that contributes to our lower Mach operating speed. So why did Boeing design the planes like this? And really it comes down to what was the purpose of the jets. 737, it was designed for 1 to 2 hour flights. Cruise times, usually 20 to 30 minutes on those shorter ones. And the time reward of having a faster wing that flew at 0.9, it would only decrease the flight time by about 6 minutes. Compare that to a 747 or a 777 that are capable of flying at these high decimal 8 numbers. And we're shaving off in some scenarios up to an hour's flight time. If we're burning 10 tons an hour, that's 10 tons of gas we're going to save, as well as the flight crew duty limits where we might be saving on a pilot or a flight attendant, etc. The third and last one is an hour shorter flight time. We can now increase the utilization of the jets flying more sectors per year. So that's fantastic, but it comes with obviously a penalty, and that is that it's not all positives when you do these wing sweeps and supercritical designs. They do produce less lift. So although they've got high lift devices fitted to the wings, which allows them to fly slower than what they should be able to do, it still does limit their speeds that they can approach at for landing, and it increases their takeoff speeds. So it narrows the types of airports they can fly to, usually to major cities that have quite long runways, particularly at high weights. So I hope that adds to what we're talking about with coffin corner, particularly on the high speed side, the max speed the plane can operate at. And I'll see you on the next one.